Hello guys, welcome back to my channel Coach Shiba. Well, we're posting my DSA content each and every day, and today is day 14th of doing so. The problem that we'll be solving today is Coco eating bananas, which is late code problem number 875. Okay, so let's see the problem. So in this problem, the thing is that there is a monkey named Coco who wants to eat bananas. There are n piles of bananas. The pile has piles of I bananas. The guards have gone and will come back in H hours. Coco can decide her bananas per hour eating speed of K. Each hour she chooses some piles of bananas and eats K bananas from that pile. If the pile has less than K bananas, she will eat all of them instead and will not eat any more bananas during that hour. Coco likes to eat slowly but still wants to finish eating all of the bananas before guards return. Return the minimum K integers such that she can eat all of the bananas within H hours. Okay. So the thing is that we'll be given with an array and we'll be given with an R. Like HR within which we have to eat all of the bananas, right? And we need to find K such that is just the minimum speed that Coco can have of eating bananas and still complete all of the bananas within 8 hours. Okay, so let's let me just like the first thing that I'll be doing throughout this video is like introduction of the problem, which we have completed halfway there. The second thing that I'll be doing is discussing different approaches to this problem, and the third thing that I'll be doing is time complexity and space complexity of this problem. The fourth thing which I'll be doing is uh, the implementation part of this problem. So let's do this first of all. So there is a monkey, as I've said, who likes to eat bananas. Let's draw this monkey. Okay, this is Coco. It will have few legs. Don't mind my drawing, like it's really bad, I know that, but just for the sake of explanation we'll be drawing something, right? So this is Coco, and Coco is a lazy monkey. It is a lazy monkey, and Coco wants to eat pile of bananas, as we have already discussed in the question statement that there will be n piles of bananas, and within n piles it will contain a variable amount of like some amount of bananas within it. So here like will we can say here it will be 3 2 7 11 bananas within this pile. Okay, and there are some guards who are securing all of these bananas, right? There are some guards who are securing all of these bananas, but these guards will be gone for a while. And for how long will they be gone? These guards will be gone for H hours. Okay, and will be provided at within the question that we like for how long these guards have gone, and they're not looking after all of these bananas so that our Coco can eat all of the bananas within these piles. Okay, it's fine. Now there are some rules on how Coco will be eating all of these bananas. First of all, Coco wants to have, because it is a lazy monkey, it wants to have the minimum K speed of eating bananas, and also complete eating all of these bananas within H hours. We like the time should wait a minute. The time with which it will be eating bananas should be smaller than or equal to the number of hours within which the guards are gone. So these are all of the conditions that we are given within this problem, and Let's definitely see a particular example and a dry run to understand it in more depth what the thing is happening. Okay, so there's one more statement that I have to tell you, and the statement is this: that for example, Coco is eating at a speed of 2 bananas per hour. Okay, so and it is at the first like at the zeroth pile. So how will it eat the zeroth pile banana? So what Coco will do is Coco will definitely divide this 3 bananas into 2 and 1, because the speed of eating bananas is 2. First of all, it will take 1 hour to eat 2 bananas, and then it will wait, like it will like 1 hour to eat 2 bananas, and then it will take another 1 hour to eat 1 bananas. So maybe like, so the thing is that Coco can eat 2 bananas in an hour, but it will take like when there is only 1 banana remaining, it will just take that 1 banana and will like sit idly for the rest of the hour. So so this is what is happening, like to eat at the speed of 2. If it is eating 3, it will take 2 hours for Coco. Like the total time, it will be 2 hours for Coco to finish 3 bananas if the speed of eating bananas is 2. Okay, so I hope you understand this statement, because it's very important one to when we are solving this problem. Let's say this example: 3, 6, 7, 11. Okay, so we are given an array 3, 6, 7, 11, and we are also given with the total number of hours which we have in order to eat all of those bananas, for Coco to eat all of these bananas. So what we need to find out is k. What we need to find out is k, right? We have to find the value of k, which is minimum, and the time that we will the total time that we will obtain from this speed, that should be equal smaller than or equal to high. These are the two conditions. So the very first thing, like if we think of a example, like what can be the speed, we can think of it in such a way that, like, we need to think in terms of parameters, right? From where can we start the value of k until when we can like stop using this value of k. We have to think in that terms. So value of k is a variable value between these two states, the initial state and the final state within the problem. Any value between these two places can be our answer, or even these two places, including all of these parameters, and all of the values between parameters can be a value of k. K can exist between all of these states, right? So the first value that I can think of right now, that the k's value can start from, is maybe k equals to 1. Like for example, if I can take k equals to 1, then the total time of eating all of these bananas will be like 3, 6, 7, 11. Okay, so as we already know that if k is 1, then it will take, like, these three will be divided into three parts: 1, 1, 1, and for eating every banana we will take 1 hour each. Okay, so that's the case. Definitely, that means it will take 3 hours to eat this banana, 6 hours to 6 hours to eat these bananas, 7 and 11 respectively, and then we will just add it, and whatever time we will get, the total amount of time, that will be our answer, right? So this is the thing that we will be starting from. We can start from 1. Like, there is a speed of, like, in 1 hour I'm eating only 1 banana. That could also be the speed of eating bananas, right? Okay, now till when, like, what is the limit of this k? till which value I can say like this is the maximum speed of eating bananas. What is the maximum? What can be the maximum amount of speed of eating bananas? So let's think about it. So if this array, if within this array, let me just think about it. Uh, 20. So yes, the array is not sorted. The input array is not necessarily sorted. It is not, yes, so it is not sorted. The input array is not sorted. So for that, what we are going to do is we will be taking the maximum element within the array. First, we need to find it, and like there is a thing to observe. If let's say k's value is equal to the maximum element within the array, which is 11, of course. If we eat all of the bananas with the speed of 11, which is the maximum element, let's see what our answer will be. We can definitely eat this banana in 1 hour, and then Coco will sit idly for the whole hour. And Coco can also eat this banana, this amount of bananas within 1 hour. Similarly, it will take only 1 hour, and similarly it will take only 1 hour. So the maximum speed of eating bananas, or the minimum time to consume all of these bananas, should be n number of times the size of the array, right? It will be 4. That's fine. It's fine. It will definitely be 4. Let's say if we take a value which is even greater than the maximum element within the array. Let's say if we choose a value such as k equals 15, we will eventually get the same answer, but I'll just dry run. Okay, let's take our value as 15. Okay, let's take our value as 15. What will happen in that case is that Coco will finish eating 3 bananas in 1 hour. Similarly, 1 hour, 1 hour, 1 hour. Because all of these bananas quantity is obviously smaller than 15. So it will again be equal to n, which is 4 in this case. So if you choose any number greater than the max element, it will result in the same condition. So our search space is now limited to k equals 1, from k equals 1 to k equals max element within the array. Okay, so the value of k is from here to here. Now this is everything that we can talk about this problem, and now if we look at the ways in which we can solve this problem, the very first approach, now the problem is really simple. As you can see, since we need to find k. Okay, since we need to find the value of k within these two parameters, including these two parameters. Okay, from k value should be from 1 to the max element, right? Max element. So k belongs to these. So the values of k can range between 1 and the max element, right? So if values of k can range from this point to this point, and certainly all like k's value, k equals to 1, then k equals to 2, then k equals to 3, then k equals to 4, then k equals to 5, then k equals to 6. Okay, all of these values are also in like sorted order, and we have a particular search space from 1 to max element, all of the elements in sorted order. What can we do within this problem to find k's value? We are we are also like searching for k value such that it can be the minimum value for which the number of hours will be fine, like within number of hours, like the time taken would be always smaller than or equal to number of hours within which the guards are gone. So we are searching in a sorted space. What is the algorithm which we use for searching within the sorted space? We obviously know it is binary search. And other than that, the other way to solve this problem would definitely be a linear search, which will obviously, like the first approach to this problem would be A linear search. But is it the most optimal? No, the time complexity of linear search is big of n, and the space complexity will depend on whether we are taking a vector or something like that. The second approach, which is the most optimal approach for this problem, it is definitely a binary search, and I've told you why. Because we are searching in sorted space, and what algorithm other than binary search is better than doing that? Because we can then have a time complexity of big of log n, which means we are definitely breaking down the array into halves, and we are choosing either of the halves. We are not choosing both of the halves, we are choosing either of the halves. So if it comes to if we visualize the tree, we'll only be going in a particular half. Will not We will never be reaching at the other point, so that's fine. Again, space complexity, depending upon if you're taking any vector or not, the space complexity will have alterations. So let's figure out how we'll be implementing binary search within this problem. So the very first thing that we had to keep in mind was the value of k and how it is uh, manipulating as we go forward. How we can choose the value of k, as I've already discussed you as I've already discussed that the value of k can be from 1 to the max element within the array, and that will be true. So if we certainly take this point where k equals 1 to k equals max element, right, within the array, now we can obviously have the basic conditions, like basic setup for a binary search. By taking low and by taking a high, we will obviously have a mid value, and when we'll have a mid value, we can always calculate, like mid value can be a k value, which might be our answer, right? So for the to check that, we will see if that mid value, like we can obviously find time. We can find time such that t is smaller than or equal to r. Okay, our task is to find the that at a particular speed the time should be uh, smaller than or equal to I, right? So we will have our task at this point, after taking out mid or after taking the value of a particular k, we will be looking forward to calculate the time within which, after taking that speed, Coco will complete eating bananas, right? So we'll find our time. Now, what are we gonna do? If this particular time that we have calculated is smaller than or equal to the total number of hours, this might be our answer. Might be our answer. So we'll obviously store this in a place like somewhere, and if another value comes of t which is smaller than this particular value, we will update it to that. So we'll have a minimum of two values. Let's say a result where we are actually storing the mid value, which is the first mid value, which is satisfying this condition, like this. We can have these two conditions, right? Okay. So how we will be manipulating uh, high and low pointers throughout this problem. So when we get a certain mid which might contain the answer, and we want to find a smaller mid, right? We want to find a smaller number. If we have taken this mid and this might be the answer, then obviously we'll be taking our high and we'll be going to mid minus 1. Okay, and if the mids value, if at a particular mid value, at like the time that we have calculated is greater than that of high, that means no value which is before mid can be our answer. So we'll be taking our low pointer, and we'll be pointing it towards mid plus 1 value. Okay, that is fine. So this is everything that we'll be doing. Now the thing that I also want to discuss within this problem is regarding the calculation of how much time it will take at a particular speed to eat bananas. Like 3, 6, 7, 11 at k equals to 15, we are calculating the speed. Okay, and then we are like doing it. So there are different ways to find the speed of it, the time obtained at a particular speed. Time obtained at a particular well of k 3, 6, 7, 11. This is the array that we're taking in as an example, and the number of hours, let's say it might be 8. Okay, so the value of k can range from 1 to the max element, which is 11. Okay, so let's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, so we'll have all of these possible values of k. Now we'll obviously have a low pointer, we will have a high pointer, and we will have a value of mid, which might let's just take, I'm not calculating mid right now, but okay, let's calculate it. 11 plus 1, which is 12 by 2, 6. Okay, so mid is here, our mid value is over here. That's fine. Now what we'll be doing is, since we know the mid value, mid is k, now we will have to find time that it is taking at k speed. So for that, 3, 6, 7, 11. Okay, what is the total time that it will take? So if k is 6, that means it's Coco is gonna eat it in 1 hour, 1 hour, 2 hours, and again like 2 hours. Yes, so the total amount of time will be 6 hours. It is smaller than or equal to 8 hours, so this might be our answer. But we'll look forward to such a number which is even smaller than that. We will check if a number exists which is smaller than this mid and can be our answer too. So we'll go at mid minus 1, high will go over here, and our search space will be squeezed to 1 to 5. Then our k will be 1, 2, 3, 4, 5. Right, this will be our search space: low, high, mid. Then if the value of k is 3, 3, 6, 7, 11, we can have 1 hour to eat these bananas, 2 hours to eat these bananas, and 3 hours to eat these bananas, and 3 threes and 9, 9 and 1 three, like 4 hours to eat these bananas. So the total amount of time that it will take for Coco to eat all of these bananas is 10 hours, which is obviously greater than 8 hours. So we will take our low pointer and we will update it. We'll update it over here. Our low will be here at 4, and 4 plus 5, 9 by 2, 4.5, which is obviously our mid will be over here in the last iteration. Yes, it will be last iteration kind of. So if our value of k is 4 and we have 3, 6, 7, 11 as the array, what we are going to do is we will just take 1 hour to eat these bananas. We will take 2 hours to eat these bananas. Similarly, 2 hours to eat these bananas, and 4 times 2, 8. We'll obviously take 3 hours to eat these bananas. So 4, 5 plus 3, 8 hours. which is smaller than equal to 8 hours that we have as a limit. So at k equals to 4, this is our minimum answer. First of all, result will be updated to 5, and then from 5 we will take our value of k as, no, first of all the value of k was 6, right? It was 6. Yeah, it was 6. Mid was 6 at first, and then mid was updated to 4, and this will be a final value. We will be returning this value after calculating the number of, like, the amount of time. Okay, so one thing that we need to keep in mind is we will have to return the seal value of like calculating this calculation which is done over here. We'll always need to take seal value, right? For that seal value we can use a seal function within C++, or we can have different if else statement. And the third way to do this is a mathematical equation. Okay, we'll be doing that. So here the thing is that we have different ways in order to calculate seal, but the first things first, why do we want to calculate seal for a particular value? Why do we need y seal of a value? So for example, if the value of k is 3, and piles of I at a particular position is, let's say, 10. Okay, so if you just calculate the floor division of these two values, it will come out to be as 3. Or if the more accurate answer of this problem might be 3 point something. Okay, that 3 point something, if we are calculating a floor value, we will have 3, or if we are calculating a seal value, we will have 4 over here. So we can have 3 as an answer or 4 as an answer. But since in our problem we have already discussed that if a particular element is here and we have different speeds of eating bananas, so we can have 10 as 3 times 3 plus the remainder. So this particular remainder will be an extra case that, like, will take an extra hour for Coco to eat banana. Okay, so we can use this division equation over here to understand this. We will have 3 times 3, but then there is some reminder, and to that reminder, that reminder will always be smaller than, reminder will be smaller, always smaller than k. Okay, so this value will always take like 1 extra hour for eating bananas. So that is why we are calculating a seal value over here. Okay, so let's directly jump into the implementation part of this problem, which is the last part, and then we'll be good to go. Okay, so let's solve this. First of all, we'll be taking size. Int low can be 1, int max can be max element. This is a function in which we need to give files dot first pointer, second pointer. Okay, sometimes we need to pass a point over here. Okay, so since we have a low and we have our high, Hmm. So after calculating mid, the first thing that we are gonna do is we will calculate. For that we will have to iterate throughout the array. Time plus equals to, okay, this is the mathematical equation that like there are three ways to calculate seal value of a particular element, and this is one of the mathematical ways. This is the most fastest way. We can either use a seal function in place of that, or an if else condition, depending on how we want to calculate seal. Okay, and the last, whatever we are using, is a mathematical equation. I'll tell you about it in a bit. So when we have calculated our time, if the time is smaller than or equal to h, this might be our answer. Okay, so we can have a value as a result over. We can initialize it to int max. Time res equals to min of res mid. After that, what we are going to do, we will take our high pointer and we will place it to mid minus 1 to look for more smaller value of res. Okay, else when time is greater than high, we will move our low pointer to mid plus 1. Okay, so at the end, what we will be doing is we will be returning our result. So yes, now let's run this code and see if it works. Okay, so our code is running. Let's submit and check if it works for larger test cases or not. Okay, so it has a little problem over here. Hmm. Okay, so we can take it as long, long. Now see if it works. Yeah, the solution is working. I guess now the code should be running. Okay, so my code is running and it works for larger test cases too. And yes, so I was like talking about this equation, right? So this equation is something like, I can like time So we have already discussed about this equation, a equals to bq plus c, right? If there is, if a equals 10 and k equals 3, what will happen is 10 equals to 3 times q plus c, or let's say r. Okay, so we will have a particular number multiplied with 3, and we will also have some uh, reminder. This reminder will always be smaller than k, so it will take 1 hour more for like some n number of hours plus 1 hour more. That will tell us the time that it will require. So 3 times 3 plus hour, it will take 3 hours, and then it will take 1 hour more, so it will take total 4 hours if the value of k is 3 and if a particular piles of I is at 10. So how are we able to use this equation? What we are actually doing is we are like piles of I plus mid minus 1 divided by mid. Let us take like 10 divided by 3 is 3, right? But I can make you understand this thing with a diagram. Let's say this is 10, okay, and our value of k is something like this. It is 3, so it will take full portions of 3, full portions of 3, 1 2, let's say, let's make even bigger blocks. K equals to 1, let k equals to 3, so 1 2 3. Now we have 3 blocks of 3, right, we have 3 blocks of 3, and this is the particular reminder. Okay, reminder is always smaller than so reminder is always smaller than k, right? If we have another block of 3 over here, let's say if we have another block of 3, it will be over here, but what we are actually adding is mid minus 1. If we add this mid minus 1, so what will happen is we are adding a little smaller block than this particular 3, so we are adding this block on a reminder. So we are adding this particular block on a reminder, which will exceed this block that we have originally built if we had like 4 total blocks of 3. So this particular block will be mid minus 1. Mid minus 1 will never exceed any another block of 3. It can come up to here, maybe it can come up to here, but it will never exceed this the fifth block of 3. So if we have 10 divided by 3, if we have like a value like 3 10 plus 3 minus 1 2, okay, so it will have like 12 as a value, so 12 by 3 equals 4. So we'll have total 4 blocks, 1 2 3, and we will have this block over here. This block of 3 will also be counted, but this block will never be counted. So we will have at least 1 2 3 4 blocks of 3. Even like if we take another value of k, for example, we take a value of k as 11 by 3, 11 plus 2, which is 13 by 3. Okay, so the floor value of this will come out to be as 4. So it is because we are calculating floor value afterwards, that is why answer will always come with these four blocks. It will never include the fifth block over here, because the mid minus 1 value, this mid minus 1 value will never exceed this particular fifth block. It will always be within the range of this fifth block, and if we calculate the floor value, we'll always get 3 blocks. We will never count the fifth block. So this is the mathematical way in order to find the seal value, and I have given you the explanation of why it works, how it works. So thank you guys for supporting me, and it means a lot that you guys are watching me. It is really, it gives me a lot of motivation to make all of these videos, and thank you guys. See you all guys again in another video in another day. And also that I haven't been posting for the past 2 days, because yes, there were some issues, but now from now on I'll be posting continuously. So thank you guys, log out.